In this video, we're going to look at how to find the zeros of a polynomial. I'm going to read the directions, making sure you understand what I'm expecting of you. Find all of the zeros using graphs. That means you can look at the graph to see if you notice a zero. So that would be your first thing you look at. The rational root theorem, if looking at the graph is not enough to get started, and then factoring and or division. And I probably ought to add the quadratic formula. You're going to need to use the quadratic formula quite a bit as well. Do not use your calculator to factor or solve. I know you can do that, but I'm not going to allow that on the test, so that you ought to not do that on your homework. Once you get your zeros, verify that all real zeros match the x-intercepts. So let's take a look at example 1. In example 1, we see the polynomial p of x, which is the same as saying f of x, only I just put a p there for polynomial. P of x is equal to x cubed minus 1. So we see on the graph that the graph appears to cross the x-axis at 1. So we're going to verify that's a 0. So if we put 1 into the equation, we get 1 cubed minus 1, which is 0. So we know that our first 0 is 1. We know then that this could be factored to x plus 1 times some other factor, and since this is cubic, we know this would be quadratic. And if we can find this quadratic factor, we can use the quadratic formula to finish finding the other two zeros. I can tell by the way the graph is curved, it goes straight through the x-axis here, that this is not a triple zero. It would be a triple zero if it curved as it went through. So if it curved as it went through, then that would be an x minus 1 cubed, or an x plus 1 cubed, sorry. But it does not do that. So I'm going to need to find the other two zeros some other way. So I'm going to divide. I know that if I take the original function, x cubed minus 1, and divide it by x plus 1, then I will get the remaining factor. So I'm going to use synthetic division to do that. So I'm going to put 1 in the box. And then we have x cubed plus 1. Now we could think of this as x cubed plus 0x squared plus 0x minus 1. And we need to have those zeros in there to hold as placeholders when we do our synthetic division. So don't forget that. Now the first thing I do is bring down the first number, which is a 1. 1 times 1 is 1. Add those together. 1 times 1 is 1. Add those together. 1 times 1 is 1. Add, and I get 0. And I already knew that I would get 0 because I already know that 1 is a 0 of the function. But that's a good confirmation. This then tells me that the remaining quadratic factor is x squared plus x plus 1. So I could write this as p of x is equal to x plus 1 times, x minus 1. I wrote that. You guys are probably crying out, half point. That should be x minus 1 since the 0 is a positive 1. So this is x minus 1 times x squared plus x plus 1. Now this, as I look at this graph, I know that these other two zeros have to be imaginary zeros. This is my only real 0, so I'm going to have to solve this using the quadratic formula. Remember that zeros are whatever we get when we set the factors equal to 0. So either x minus 1 equals 0, in which case I get x equals 1, or x squared plus x plus 1 equals 0. Since I can't factor that, my only option is to use the quadratic formula. I expect you to know and to be able to use the quadratic formula and to be able to simplify. So let me just remind you that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you don't know that, you need to have that memorized. My a, my b, and my c in this case are all 1. So I have x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. That's negative 1 plus or minus the square root of negative 3. See, there's where our imaginary number comes in, all over 2. So that's negative 1 plus or minus the square root of 3 times I. Remember, I is outside the radical. That's important. Now, to simplify this, divide each of the terms in the numerator by the denominator. So we're going to have negative 1/2 plus or minus the square root of 3 over 2i. So this is our real part and our imaginary part. Remember I told you that imaginary roots occur in conjugate pairs. So here are our zeros. The zeros are positive 1, negative 1/2 plus the square root of 3 over 2i, and negative 1 minus the square root of 3 over 2i. So those are the three zeros of the function.